Hello, in this tutorial I want to show you two main things. First is how I added skin weights procedurally to the jet nozzle, and second is how I used Python that helped me set up constraints for the 112 bones at the jet nozzle. One thing I would also like to clarify is that I'm starting with a complete model. You could have all your UVs and everything set up, all your geometry, all your topology, and I'm not just taking one part and setting it up and duplicating it around. Even though it's not super complicated, it is a fairly advanced tutorial, but you will learn a lot of useful skills. So let's get started. Okay, so since the last part, I updated the rig a little bit, but the principle stays the same. We have the geometry setup, the skeleton setup, constraints, and the skinning, and finally the deformation. So let me show you what changed in the geometry setup. So we're starting again with the alembic, unpacking it, and now again splitting it by parts. This will be the movable parts. Unmovable parts are here, and this is basically the same, but what I changed is I switched from groups to an attribute. The attribute is called name, and we will match the bones with the attribute and the skinning. So we are no longer using groups to assign weights to a bone. We are using a attribute which is called name, and we will match the bone with these points on the geometry. And I'm using a little script to assign points to assigning the attribute to specific points. So this is for the left part, and this will be for the right part. So I don't have to use a manual selection. I can use this little script, which is very helpful. I don't have to use another setup. So that's what changed for this. And if you want to make your life a little bit easier, and you can select all these nodes that we are creating here, and just duplicate them and use them for the groups, for creating the name attribute. So you don't have to fill in and copy in all the names by hand. You can save some work and just use these pre-made nodes. Good. So for these parts it's easy. The engine is the complicated part a little bit. So the way I approached it is I separated the engine, the movable engine parts, and each ring is now separated. I'm gonna start explaining at this ring because it will be easier for me to explain. So in here I'm trying to separate just one of these parts, and the way I modeled it, I have all these rings as one object. Probably the best way you could approach it would be to have each of these flaps, or I don't know what it is, as a separate object, and then it would have a separate path attribute, and you could use that. You could use that to create the name attribute, which I'm doing somewhere here. and you will make your life a little bit easier with that. But if you don't have the option, you need to find out some other way. And the way I did it is I tried to separate one of these flaps. Now I'm duplicating it, and I'm creating this attribute, which will be just an integer from 1 to 15, because we have 16 in total. Now I promote this attribute from primitive to point, and I'm creating the name attribute for each of these flaps. So now, because I combined this copy number, which goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, and I combine it with my custom name, which is basically the name in here. So this is 2a, so we have this name, and I created an attribute which is the same as it will be on the bone. So now I'm just transferring this attribute to the geometry, and if necessary, I will promote this attribute to the whole part, which I can show you at this first example, because now you can see the parts are overlapping. So I can't just simply procedurally separate one part. So the way I did it was split this little selection which is not overlapping, duplicated it, created that created that name attribute. So now I can see each one of them has a unique name attribute. And now I transfer this to the original geometry. I find connected parts, and now I just promote it so it's on the whole part, this one name attribute. So really the point is just to have a name attribute on each of the flaps that matches the bone attribute, the bone name. That's all you need to do. The way you do it, it's up to you, and it might change depending on your model. This approach might not work for your model or what you are trying to do. And I did this for each of the engine nozzle rings. So as you can see, the name always changes, and it corresponds with these bones. And these bones, it's very simple. I just created bone, put it into position like before with the rig pose, and then I just duplicate it. And again, creating a name for each of the bone using this little Vex script. So here we have bones from 0 to 15, so 16 in total. Again, for each of the rings. So we get something like this at the end. Now, one thing that I would like to point out is notice how all of them are pointing in the same direction. So the y-axis is pointing upwards, and I'm using the x-axis for rotation, and the z-axis is pointing to the back. So be sure to match the orientation. So the visualized rig node is very helpful for this. Right, so let's have a look at the constraints. So for the flaps and for the wings, flaps and rudder and elevators, nothing has changed. It's pretty much the same thing as it was before. I just added a few rig constraints for each of the engine exhaust nozzle ring. I could do it in one rig wop, but I just found it to be more convenient to have one rig wop for each of the ring, one wop node for each of the rings, because there's quite a lot going on inside, so I just find it more convenient to work in this way. But you can definitely put it all inside one rig wop. And if I dive inside and have a look, you can see it's the same thing as previously. We have for each bone we have a get point transform node. We offset the transform, so we offset the rotation of each bone, and we write out this transformation. And I'm using a channel, and the channel is basically this null. So if it moves back and forth, it goes from 0 to 1, from 0 to 2, and we will use this number to offset the rotation. So let's go back inside here. So I'm reading this channel, this movement. I'm just clamping it to 0 and 1, and I'm fitting it to 0 and 1. I'm actually thinking about it. Maybe I just let me just see. Does it? Okay, so yeah, because I'm clamping it, it's not doing anything after the value 2. So I'm really using just the 0 to 1 range. Maybe I could just fix it. Okay, let's leave that as it is for now. Okay, and we're just fitting the range from 0 to 1. Just to be sure we're working in that range. And now we're creating a vector from it, which will be used for the rotation. So because rotation is in 3 axes, we are creating a vector, so 3 values, and I'm using a null just to keep it tidy. Maybe you would need to add more rotation, more transformations for the translation, for the scale, or whatever you need. So this is just a neat way to organize it. And this is done for each of the bone of each of the engine ring bones. So as you can see, it's basically the same. And what I did is I also promoted this value. This will be the rotation angle, destination minimum and maximum. So this will be the angle, the maximum and minimum angle which the flap can rotate. And I promoted these attributes so I can work from the outside and maybe even change all of them at once. So here you can see the angles change slightly, and I fine-tuned these values. Right, but let me show you how you can use a Python script to help you set up this process, because if I wouldn't use a Python script, I would have to connect all of them manually, and if the name or something would change, the number, if it would change, this will be very tedious to redo, and it would be also actually quite tedious to set it up. So that's why I used a Python script, but you can definitely do it by hand. Alright, let me show you how you can use a Python script to automate this process. So first I select only one ring of the bones. Now I rig VOP, connect it. I'm actually gonna steal this from this one. Right, so we have the channel, clamp it, fit it, make a vector out of it, and create a null for the output. Now this name is important. I'll show you later why. Alright, so now I press enter, select all of the bones and drag them in. It doesn't work, so I'm just gonna go outside, maybe put the visibility node on it, escape to deselect everything, go inside, again enter, select everything, and drag and drop it, and now we have all the nodes. So I can select everything, and now I'll press my custom script, and as by magic, now everything is connected to that output, the rotation output, and everything is set up correctly. So if I would go in here, where do I have these controls? Okay, they should be outside in here. If I would, actually I'm just gonna use this, I'm just gonna duplicate it to show you that it should be working. So this is the scale. Right, so let me just change. Alright, so it's actually reading the value from the channel, so as you can see it rotates just as this null moves. It moves, the bones rotate with it. Let me show you what the script does really quickly. So edit and script. Now it's fairly simple. So what it does is we get a list of the selection, and we're gonna do something to each of the selection, to the node, each of the nodes in the selection. Now if the node type is set point transform, so basically this one, I want to delete it because I'm gonna create my own one. And if you notice, if I drag them in, I couldn't just select get point transform. So that's why it's just easier for me to delete it. So I don't have any duplicates or anything, and it's easier for me to delete it and then just create it than to try to somehow connect it and arrange it. So if the node type is this one, the get point transform, I'm gonna set up some paths, a path to the node, and this path to this node, and I'm gonna create this offset transform node and set the connections. Set the connection to the get point transform. Basically create this connection, and then I think create this connection. It should be this line of code. And now this will just align it so it looks pretty. Next, it will create the set point transform, and we gonna also create the connections. So this connection, this should be this one. Move it to good position so it's pretty. And next we're gonna set the signature to by name, because if you create a set point transform, okay, so it's in here. If you create one by default, the signature is by name or by point number. I'm not sure, I think, or if I change it, revert to factory defaults. Wait a second, revert to factory defaults. Yes, so the default is by point number. So I need to set it to be by name, and then I will set the point name to basically this one, or this name, and we will also set the name in here. So I will set the point name in here and the node name in here. So node name first and set name in here, or at least I think so. And at the end it will just lay out all the nodes, and that's it. Now I'm a beginner in Python, so this might not be the best or the optimal way to do this, but it actually works, so that's fine for me. I will continue to improve it in the future. I will continue to improve my Python skills in the future. Alright, and let's move on to another interesting part of this video. So we have all the geometry and all the name attributes set up, and we have all the skeleton and parenting, everything, and rigs, and the rig and the constraints set up. And now we need to actually bind the bone to the skin, and we will do that in here, and we will do it procedurally. Okay, so the way I did it was I initialized the values. So if I would visualize how it looks, so this is how it looks. So it's a bit messy at this point, but it doesn't matter. I'm only looking for the node to initialize all the attributes that I need. And now this is a funny thing. These attributes are, I don't quite understand it, but they are packed, and the documentation says it's something because it's easier to work or easier to, I don't know, to manage them when they're packed. Anyways, to be able to actually somehow usefully edit them, you need to unpack these attributes. So maybe if you see the attributes change and you get some new attributes, and also in here you get some new attributes, and now we can use them and to edit the weights and which bone is assigned to which point. Okay, and this is how it works. You unpack the weights, and now you get this array. And what's important is that the bones have a specific place in the array. So they go from the first one, which is the main, second one, third one, fourth one. And this number, for example, 0, 1, 2, 3. So if I assign to a point that, actually, if I want a point to be assigned to this bone, I need to somehow assign the number 3 to the bone capture index. So this means this point is assigned to the bone number 18, and this is driven by the position of the bone in this array. So if I want to assign the point to the bone main, so the main part, they need to have a value of 0 in the bone capture index. So let's examine. Good. So if I would select this one, you can see it's bone number 19, but this one is actually bone 0, which means this one is assigned to the main bone and will move with this bone. Okay, but now how do I assign my custom weights? For that I created this little Vex script, and what it does is it gets this array attribute, and for each point, let me just select one point. For each point it goes through this array, and if the name attribute on the point matches one of these values, it will assign the position in this array to the point. So for example, if these match, it will assign the 0, 1, 2, it will assign a value 2 to this attribute, bone capture index. So really the key to this method is unpacking the skinning attributes and getting the bone position from this array and assigning this number to the bone capture index. Then you just pack the attributes again and everything is working as it should be. Alright, so that's all for now. Thanks for watching. Hope this was useful for you, and see you in the next one.